Welcome to Mathy Python, Beginner Python series, episode 9. We're talking about loops. So last episode, we learned how to make decisions with Python with if-then statements. Today, we learned to make Python repeat itself without writing the same code over and over. The way that we repeat a process is through loops. For example, we can process collections by iterating through over them, generate sequences, and we can also avoid copy paste code that becomes a maintenance nightmare. What if you have to change something? Do you really want to change that in 50 places, 100 places, more? So that becomes a maintenance nightmare. Also becomes a petri dish for bugs. So let's look at for loops over a list. So the idea is you have a list of items and you want to look at every item and then do something with them. So let's suppose we have scores 88, 92, 75, 100, 84. Then I can iterate through these. So for, I'll call it score in scores, print score. Okay, so it loops through. First time through, it looks at the item at index position 0, which is 88, then index position 1, which is 92, then the next one, 75, 100, and then 84. This variable score, this is created in the for loop. You can call this anything you want. I could have called this X, doesn't matter. Could have called it Fred. Doesn't matter. What I like to do is name my collections with a plural, so like scores with an S, and then use a singular to step through it. That's just a personal convention. It's not required. It's not even Python convention. It's just something I do. Okay, so we have a list of items. I say for score, whatever you want to call it, in scores, then do something with it. Variation of this, I could say score, let's give everybody a curve of 10%. That's generous. And yeah, let's just do that. So we have scores, and 110% of 88 is 96.8, etc. Let's clean that up a little bit and say round that. Now we get 97, 101, 82, 110. Okay, we can look at range. Range is an object in and of itself, like a list or a dictionary or something. It's a different kind of object, but it's still an object. Sometimes you want to repeat something a fixed number of times, not loop over an existing collection. That's what range is for. So this is if you're counting over a loop. So what do I mean by that? I can say for I is convention for index. I, J, and K are often used when you're iterating over a range, although you can use anything you want. So let's say I say for I in range 5, and then I print I. So this prints 0, 1, 2, 3, 4. So the range, by default, the start value is a 0. And then it goes 0, 1, 2, 3, 4. When it gets to 5, it stops. It does not include the 5. So same as we saw with string slicing or list slicing. The beginning point is, the start point is included, the end point is not. I can explicitly say 0 to 5 if I want, just to make it clearer maybe. I could start at 1. So again, 1 to 5, 1 included, 5 not. 1, 2, 3, 4. Let's go 2 to 15. Let's say 14. Every other one. So now I have the start, the stop, and the step. So this will start at 2, skip 3, do 4, skip 5, do 6, so forth. And it does. So it's 2, 4, 6, 8, 10, 12. Does not include the 14. Does not include the endpoint, just as before. So range, you can conceptually, you might think of this as a list that's been created and then it iterates over it. It doesn't actually work that way. It doesn't build a list in memory first and then iterate over it. It generates the values one at a time as the loop asks for it, which is more efficient in terms of memory. So if you had range a trillion, then rather than create a trillion numbers, it just creates them one at a time and throws the other one away when it's done with it. There are a lot of patterns in programming, so templates that you use over and over to accomplish some task, so that you don't have to reinvent the wheel every time. So we'll see a lot of patterns. One of them is what's called the accumulator pattern. Accumulator means that you are accumulating something. So you loop through and then you're adding to maybe a total. So for instance, for score and score, total plus equals score. And then let's print the total. For score and scores. There we go. Right, so for score and scores, the total is initially 0, so it's initialized to 0. And then the first time it adds whatever the first score is, it adds 88. Then the second time through, it adds 92, then 75, then 100, and then 84. If you add all that up, you get 439. This is often used to, this pattern is often used to find the mean. So if I print the total divided by the length of the scores, then we see the mean score is 87.8. Also look at the plus equals. We could have written total equals total plus score, meaning you take whatever the score was, or excuse me, whatever the total was, add the score to it, and then reassign it to total. As we've seen, this line, total plus equals score, is just a shortcut. We also use this pattern to build up a list, for instance. So we could say doubled empty list. So that's a list with nothing in it yet. Then say for score and scores, colon, because the colon tells us that we will run the block of code in this for loop. And then we indent it to say where the block starts and ends. In this case, it only has one line. So doubled append, let's say score times 2. And then we'll print doubled. Okay, so 88 doubled is 176. 92 doubled is 184, and so forth. Notice this indentation is necessary. If I had this at the same indentation, then it will run with the for loop. The fact that there's a blank line here doesn't really mean anything in this context. So all of the code that's under the for loop, indented under the for loop, is considered part of the code that gets run in that for loop. When I push the indentation out to the same level as the for, that means it'll run the for loop, do whatever, and then it continues with this code. There's another kind of loop called while loop. So we were just looking at for loops, and for loop says do this thing for each item in a collection, or do this n times. While loops say keep doing this thing until the condition is no longer true. So you typically do not know how many times you're going to run a while loop. It just goes until you're done. So, for instance, let's suppose we have a certain amount of money that we're going to put in the bank with an interest rate, and we want to know how many years pass until our balance has doubled. So, let's say our balance is 1,000. Our rate is 5% per year. Number of years, initially it's 0. Then we say while the balance is less than 2,000, doubled, colon. Balance, the new balance is multiplied by, in this case, 105%, 1 plus the rate. And then let's kick the years up by 1, increment years by 1. So the balance will go through the loop and keep increasing by this rate year over year until it is not true that balance is less than 2,000. So when it hits 2,000 or above, it will stop the loop. Then it goes to the next line of code. I'll use an F string. I'll say balance doubles after whatever the value of the variable years is, and then the word years. The balance doubles after 10 years, 50 years, 2 years, whatever it turns out to be. And it doubles after 15 years. So we're compounding a balance of 5% annual growth and asking how many years until it doubles. We don't know that number ahead of time, so we couldn't use a for loop because we don't know how many times. Right. So a for loop needs you to already know that number of iterations. Here we don't, so we use a while loop instead. There is a danger called an infinite loop, which can happen. It's a common bug. So let's say I forgot to add in the rate with the balance, and I say balance is balance times 1. Well, that's going to give me the same balance, so it's never going to double. So if I run this, now I'm stuck. So the code just does whatever it is you tell it to. So it will just run until you stop it. And I know it's running because in Jupyter, there's this asterisk between the brackets. That means that code is running. And it won't stop. And so I look at it and I realize, oops, I forgot to put in the rate. So I can go up to the big stop button here. Click that. It tells me keyboard interrupt. I'm sure there's a keyboard shortcut for that. But it basically means that the user, me, forced it to stop. So at this point, I can realize that what I meant was 1 plus the rate, and now I get the right answer. So if your notebook ever seems frozen and you suspect an infinite loop, you can click the stop button up here. Sometimes it's useful to change a loop's normal flow. So you might want to break out of the loop entirely, or you might want to say skip this particular iteration of the loop. Break exits the loop entirely. So here's a common pattern. So let's run a while loop, and it will run forever. It'll be an infinite loop until something inside it decides to stop. So I'll say while true, response is input, enter a score or the letter Q to quit. And if response is the Q key, so again, double equals is asking the question, is response equal to, in this case, the Q key? Colon, put break. This means that if you do get a Q from the user, it'll just break out of the out of the loop. So let's say you entered whatever the value of response is. Then I'll put a print outside of the loop that says you quit the program. Okay, so I run this, put it in a W, it keeps going, a 4, big string of stuff, keeps going. Press Q, and it quits. So this is called a game loop because you see this pattern in games a lot that it just keeps going until either your character has died or you quit the game. Continue skips to the next iteration without ending the loop. It just skips this particular iteration. So for score and scores, if the score is less than 80, continue. We'll print the score. Again, the scores 88, 92, 75, 184. So it iterates through these scores. If the score is less than 80, then it just stops, goes back to the top of the loop, continues to the top of the loop with the next iteration and goes through it. So if the score is 80, it skips to the next one, and then it will do that. So 88 is greater than 80, so it prints it out. 92 is greater, prints it out. 75, it's less than 80, so it just continues with the next one and doesn't do anything more with the 75. The 100 is not less than 80, so it gets printed, same as 84. I could have also written this with an if else statement or with a different if statement. Yeah, I just wanted to make the point with continue. Sometimes you want to loop over two things at once. It could be parallel lists. Maybe you want to keep track of the index for some reason. So you can loop over multiple things at once without having to write some messy code. As an example, let's say we have a week of daily high temperatures and you want to find out which day had the biggest jump from the day before. So let's say our temps are 58, 61, 60, 72, 70, 68, and 75. These have to be Fahrenheit, assuming we're on the planet Earth. So to compare each day to the previous one, you need to know where you are in the list, not just the temperature itself. So somehow we have to keep track of the index. So I'm going to call the index I. It's initially 0. The biggest jump, the difference between the two temperatures, that's initially 0. The day, so the index of the day, let's say that's initially 0. Then we'll make a for loop for temp in temps. if I is greater than 0, we're going to compare the temperature to the previous temperature. At the beginning of the list, there is no previous temperature, so that would not work. We'll say the jump is the absolute value of the current temperature minus the temps in the previous index. So we'll have to keep track of the index. If jump is greater than biggest jump, then our biggest jump is this jump. The jump day is I, the index of whatever temperature we are on. And we have to increment the index. Then we print another F string. The biggest jump was the value of the variable biggest jump. Degrees on day, whatever the jump day is. Okay. And it says the biggest jump was 12 degrees on day 3. So we go through, well, let's see what the differences are. So it'll be plus 3, minus 1, plus 12, minus 2, plus 7. So the biggest jump out of that is 12. And that happened on day 0, 1, 2, 3. So that works. Nothing wrong with this solution. It works. It's fine. But most of the loop is bookkeeping. We have to hand track I, just so we can look back one position to grab temps of I minus 1 right here. And we're wrapping the whole body in this if I is greater than 0, just to skip day 0, which has no prior day to compare against. So if you forget to increment the I, for instance, this is going to give you a bug. We could instead get rid of I. Scroll up here. It would be nice to say for I, temp, and temps. It won't quite work because temps is just a list. So it's only returning one thing for each iteration of the loop. In order to get the index too, we use enumerate. And then that will return the temperature, the next temperature, and also its index. Okay, still works, gives the same answer. So I got rid of the I equals 0, and I also got rid of the I plus equals 1 line. We could also say for I temp and enumerate temps, but I would like to start from the first element. So rather than index 0, I'll start at index 1. And then I need to tell it what is the value of that first I, and it will be 1. So we're looking at the list from the 61 on. We're skipping that first element. And then the initial start value for I will be 1. So we don't need that I. Yeah, we don't need that I greater than 0 anymore. So we saw 3 versions with the same answer. The point is not that any one of these is correct or not correct. It's that as the logic gets a little more demanding, manual index bookkeeping is where bugs tend to creep in. Now a different problem. Let's say you have 2 parallel lists, names and the corresponding scores, and you want to find out who scored above 90. So I could say names equals Alice, Bob, Carol, Dave, Eve. And then the scores, Alice got an 88, Bob got a 92, Carol got a 75, Dave got a 100, and Eve got an 84. So I could say for I in range of the length of the names, if the score sub I, that particular score is greater than 90, then I'll print the name at index I of names and the score at index I of scores. This works. So Alice had an 88. Her score is not above 90. Bob had a 92. Carol had a 75. Dave had a 100. Eve had an 84. So only Bob and Dave have scores above 90. It's also a little fragile. You're trusting that both lists stay the same length and stay aligned. If one of them gets out of sync with the other, you get wrong answers, but no error to warn you. Another way to write this is for name score in. You'd like to say name scores. That's not quite enough. I have to say in zip names scores. If score is greater than 90, print name and score. Okay. So this, I would argue this code is more readable. It's less error prone. It's a little more intuitive. So for name score in zip names scores, name is iterating through names, score is iterating through scores. If the score is greater than 90, print out the name and the score. Loops are how Python repeats work. For loops over collections and ranges, while loops for open-ended conditions, the accumulator pattern for building up results, and break or continue for controlling flow. And when index bookkeeping gets risky, enumerate and zip can help clean it up. For the next episode, we'll look at functions. So that's how to encapsulate or package up logic, give it a name, and reuse it. As usual, the notebook link is in the description. If you like this content, please like and subscribe. Thank you. Happy programming.